Hey everybody, we're going to be talking about Coulomb's law today, but before we jump into Coulomb's law, we're going to talk about magnets. The reason being is that the principles we learn from magnets are actually super applicable to Coulomb's law. So let's jump into those principles. If we have two magnets, we're first going to know that if there's a north side and a south side facing, or opposite sides, they're going to attract. We further know that like sides are going to repel, and so if we have a north and a north side, this magnet's going to go this way, and this magnet's going to go this way. The other thing we know but don't really quantify often is that distance affects how strong those magnets interact. And so first we know that as distance decreases, the forces between the two magnets are going to increase, and so I'll just draw kind of big arrows showing that it's a big force. Alrighty, and then in reverse of that would just be as distance increases, force decreases. And so if these are further and further away, this arrow is going to be a little smaller, and this one's going to be a little smaller, until there's practically no force at all if you keep pulling them away. And so with those principles in mind, we're going to actually just jump straight into Coulomb's law, but I'll leave these principles up here for you to remember. So Coulomb's law is actually a law that helps us determine the force between two charged objects. Now it's important to realize, just for the sake of this class, that the force you experience when you put two magnets together, or the opposite sides as you're pushing them and you feel them push apart, that's not the same force that is caused when you have two charged objects. So this force can be calculated with this equation. Force equals K, which is just a constant, and that constant changes depending on the medium, but in a vacuum or in air, it's 8.99 times 10 to the 9th. Newtons times meter squared divided by coulombs squared. Q is just the charge of the object. It can be negative or positive, and if it's the same sign, it's going to be repelling, and if it's the opposite sign, it's going to be attracting. And then the last thing is, of course, R, which is distance in meters. Now, we'll just take a quick look at a little example. If I have two helium atoms, and one has a negative charge and one has a positive charge, like we talked about here, opposites attract. So this will be attracting, and it will be like that. So this is all fine and dandy, but what does charge actually consist of? What causes something to have a charge? Well, charge is most easily understood if we jump down into an atom. So let's take a look at a helium atom like we had on the last slide. In a helium atom, you have two neutrons, you have two protons, and then you have two electrons. Now, neutrons are neutrally charged, protons are positively charged, and electrons are negatively charged. And so this helium atom that's very stable has the same amount of electrons as protons. And so we'd say that it has a zero net charge, or no charge. Now, the charge of an electron and the charge of a proton are the exact same with opposite signs in coulombs. And so again, since we just have 2 and 2, the math just cancels them out and we have zero charge. But what happens if we bring in an extra electron? Well, these electrons are going to try to get as far away from each other as possible. And then we now have 3 electrons to 2 protons. So negative 3 plus 2 gives us negative 1, and so it would be a negative 1 charge. However, if we were to get rid of 2 electrons and we had 2 protons to 1 electron, you'd have a positive 1 charge. Now, this is important to understand because that's all that charge is. If you have, say, a shirt, it's full of different atoms, and each atom has protons and electrons, and all you have to do is calculate the number of electrons to the number of protons. That ratio will tell you if there's a charge. And if, again, there's more electrons, you'll have a negative charge, and if there's more protons, you'll have a positive charge. So knowing all this and having this context, let's actually try a practice problem. I've given you some resources down here to help you answer this question, but pause the video and give it a shot. All right, hopefully you're able to give that a shot, and I will do the work here so that you can compare your answers. So what is the force? So F between an electron and a proton, so we'll get the charges from here, given that the distance between them is this value. So force equals K times the absolute value of Q1 times the absolute value of Q2 divided by R squared. Well, force equals, we know K is 8.99 E9, and then make sure you use your units because units actually help you check your math. So we've got the units there, and then times the absolute value of charge of an electron is negative 1.602 E negative 19 coulombs. And then we'll just multiply that by positive 1.602 E negative 19 coulombs. Close the absolute value, and then times it by the radius, which is given. All right, now you'll already notice the meters squared are going to cancel out, and when you multiply these coulombs together, the coulombs will become a coulomb squared, and they'll cancel out with this, and so all we'll be left with is newtons. And that shows that you've done your work right, you've set up the problem right, and now all you have to do is plug in the numbers. And when you plug in the numbers, you'll actually end up with force equaling 8.745 E negative 8 newtons. Hopefully you got that answer, and we'll jump into one more practice problem before we end. All right, so why don't you pause your video again, give this a shot, and then I'll do the work when you guys get back. All right, welcome back. Let's jump in and do the work. What is the distance now between two molecules, given that the force equals this value, and then the charges are here? Well, I like to solve things symbolically first. So we know that force equals K Q1 times Q2 divided by R squared, and we need to solve for R. And so all we have to do is multiply by R squared, and that gives us F times R squared equals K Q1 Q2, and then divide by F, and that gives you R squared equals K Q1 Q2 divided by F, and then you just take the square root of both sides. And so that gives you R equals the square root of K Q1 Q2 divided by F. Now, we've been given all the values, and so I'm not going to write them all down this time, but after you plug in all of the values, your answer should be that the distance between the two objects is 2.283446257, and you can round that, of course, (-9 meters). Now, keep in mind, if they ever give you any units that aren't meters or coulombs, you're going to have to make sure that your units all match so that they can cancel out. But other than that, these are pretty simple problems, and they're pretty simple no matter how far you get into physics. So hopefully this will help you get a good start, and good luck.